Lesson 16 is on the computation, again, can't draw a line, of the slope of a non-vertical line. Computation, that is like the numbers, the adding, the subtracting, like the number crunching. But it's on the slope of a non-vertical line. So I want you guys to remember this word slope right here. It might be new to us now, but we already really know what a slope is. We've just talked about it as in different terms because of the problems we were doing, but the slope is our constant. Remember, that's the number we're multiplying by. The slope is our constant. Sometimes referred to it as the unit rate. Sometimes we refer to it as the rate of change. And one we haven't got to yet, but we will later on, it's also the scale factor. So there's just a lot of like different terms we use. So the slope isn't necessarily a new thing to us, but we're talking about the constant, the unit rate on a graph and comparing it to the steepness of a line. So it says using what you learned in the last lesson, determine the slope of the line. Well, the last lesson we were doing rise over run. So remember, when we're doing stuff like rise over run, you want to make sure you pick 2 points on the graph. And it doesn't matter the 2 points. But don't pick a random one like in the middle right here, because how are we supposed to count from that? Rise over run is we're counting these unit squares. So kind of look and, make sure you pick them that kind of go through the grid lines. By the grid lines, I mean, this is the point 2, 1. It's not 2 and, I don't know, a half and who knows what. This is the point 3, 4. Make sure you put them on the grid lines. So if I go from here to here, I'm rising 1, 2, 3 and running 1. And this is kind of what sometimes you'll hear referred to as your slope triangle, right? Rising 3, running 1. Slope is 3. Excuse me. Now, but what if you didn't pick those points? What if you picked, what if you picked, let's say, this point right here and this point right here, okay? That's where it's going to kind of hit here. So I'm going to rise 1, 2, 3, 4, 5, 6 and run 2. So if I were to do rise over run, this is why it works for any point. This is a ratio of the rise to the run. It's going to rise 6 and run 2, and that's a ratio of 3. Or maybe you pick this point down here and you want to, I don't know, go up to, I don't know, this point here. It might be the same. Okay, not that point. Let's say I want to go up to this point here. All right, so I'm coming up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going over 1, 2, 3. Well, guess what the ratio of the rise to run is when it's 9 over 3. 9 divided by 3 is 3. This is why it doesn't matter the point you pick, because it's not a point on the graph. Okay, a lot of times I will see people write 3 over 1 as 3, comma 1. No, 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 no. It is a ratio of the rise compared to the run. How much are we going up compared to how much are we going over? And no matter what point you pick, that ratio is going to stay the same. Why? Because it's constant, because it's going up at the same unit rate. So what happens though? So hopefully you understand that about rise over run with slope. But what happens when we don't want to have to do it on a graph? Well, we're going to use a graph, but I want to show you a different way to figure it out. Okay? So just for this right now, let's say I pick 2 points on the graph. I pick this point right here. This is the point 0, 1. Again, it is a point on the graph, not halfway in between where we're guesstimating. And let's say I pick this point right here. It's going through the grid lines. This is the point 2, 5. Now, old way of finding slope, rise over run. So from here to here, I'm going up 1, 2, 3, 4. I'm rising 4, and I'm running 2. So I'm going to rise 4 over 2. The ratio of the rise to the run is 4 over 2. If we divide that out, the slope is 2. Means for every 2 we go up, we go over 1. But we also have something called the slope formula. And let's talk about what the slope formula means. The slope formula is this. M, I don't know why it's M. No idea, okay? I'm sure there's a good reason for it, but it's M. And that it means we're going to take the difference in our y values over the difference in our x values. Okay, what does this whole y value, x value thing mean? Okay, well, notice our up and down, that's the y-axis. So when we're taking the difference in our y values, we're actually figuring out how much it's rising. Our x-axis is the horizontal, right? So when we find the difference in our x's, we're trying to figure out how far over it goes. That's our run. So this basically is the same thing. But remember, this lesson is on the computation, like the math, the adding, subtracting, multiplying, dividing, the figuring out the slope. And we can do that without graphing it. Yeah, it's pretty easy on the graph, but not if you have bigger numbers, not if your scales don't go by ones. So let's show you how we use this. We have our two pairs, right? 0, 1 and 2, 5. Now remember, this is x coordinate, this is y coordinate, this is x coordinate, this is y coordinate. What you do is you identify one of the points to be your first point. Let's take the first one. So I'm going to say this is x sub 1, y sub 1. I'm just identifying that as the first point. Then we have x, y over here. Again, it's going to be an x, y coordinate, or x coordinate, y coordinate, but I'm going to say this is my second point, x sub 2, y sub 2. So I have m equals, now y sub 2. If you have your formula here, you're just plugging numbers in. My y sub 2 is 5 minus, because we're subtracting, whatever my y sub 1 is. Well, my y sub 1 is 1. Then I take the difference in my x's. My x sub 2 is 2 minus my x sub 1, which is 0. 5 minus 1 is 4. 2 minus 0 is 2. 4 divided by 2 is 2. Notice we get the same thing, okay? So our slope formula is going to, it's doing the same thing. It's trying to figure out how much we're going up from point to point, or rising, or going down. And we're trying to figure out how much we're going over. That's our run. Okay, so our slope formula is just doing the same thing, but we don't necessarily need a graph for it. So let's look at another example. We're going to ignore, sorry, I should delete this out. What is the difference? What is different from the last two examples? No, we're just going to find the slope of this line right here. Okay, so pick 2 points on the grid line. This one looks like a good point, right? This is the point 2, 1. And how about up here? This is the point 11, 7. Okay. So again, these are x coordinate, y coordinate, x coordinate, y coordinate. We have our slope formula. Our slope formula is the difference in our y values, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Once you have this down, okay, and again, m stands for our slope. Don't wonder why, it just does. Identify one point to be your first and one point to be your second. So I'm going to say that this is my first point and this is my second point. And as you're going to learn later, it really doesn't matter which one's first and which one's second, because again, it's the ratio. So once you have that, you just plug what you know in. Y sub 2. My y sub 2 is 7 minus, because it's always subtracting, my y sub 1, which is 1, over my x sub 2, which is 11, minus my x sub 1, which is 2. Now, it can get confusing, so it's really important that, honestly, guys, the more you write down, the easier it is. You're like thinking. You don't try to memorize things, just identify things and plug them in. 7 minus 1 is 6, 11 minus 2 is 9. Now, we can reduce that, and it's kind of important to reduce here. But I can't just divide 6 by 9, okay? That's going to give us a repeating decimal. But 3 goes into both of them, and I can divide them both by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So our slope, our m, is 2/3. Now let's talk about what this means. This means this is our rise over our run, right? We're rising 2, we're running 3. So let's look at that on the graph. If I go from here and I rise 2 and I run 3, notice I'm on the line. All right, let's keep going. What if from here? If I rise 2 and I run 3, I'm on the line. If I rise 2 and I run 3, sloppily, I know, I'm on the line. So that slope is telling us that we're going up 2 and over 3. Now remember I did say though that we could refer to this as a unit rate. Well, we can refer to this as a unit rate. We can say we're going up 2/3 per 1. Our rise is 2/3, our run is 1. And this is going to work as well. So I'm going to start from this point here just so we can see. If I go up 2/3 of the way, right? If I go up 2/3 of the way and over 1, notice I'm on the line. If I'm breaking these up to thirds, if I go up 1 2/3 and then over, I'm on the line. If I go up 2/3 and over, I'm on the line. So however you want to look at it, rise 2, run 3, go up 2/3 for every 1 unit you go over, you're still talking about this line. You're still talking about the steepness of this line. Slope, we can use our slope formula to compute it. But notice that we write it, if it's not an integer, we write it as a fraction, as a ratio, because we're comparing rise to run, not ordered pairs. This number right here describes the steepness of our line.